Hello everyone, I'm Dr. Naresh Kumar, Assistant Professor from the Department of Electrical and Electronics Engineering, Institute of Aeronautical Engineering, Hyderabad. Today we are going to have a discussion on basic chopper operation, chopper introduction, so why we need chopper and control strategies of chopper circuit. So first here, what do you mean by chopper? So chopper is a static device so which converts a fixed DC voltage to variable DC output variable. So here it is a DC to DC converter. So input is DC and output is DC. So both are input and output, both are series. But here input is the fixed voltage or fixed power. Here output is a variable power. So here this is the DC output voltage, that is fixed voltage, and variable output voltage, that is DC. So now here, so why we need this chopper circuit? So here this is one circuit, this is circuit, this is load here, out input voltage is suppose 100 volts. So now here output voltage, here we need 50 volts. So how to convert this, how to reduce this 50 volts? So by conventional method, by inserting one resistance here, that is R. So that resistance drop voltage is 50. So this 50 voltage plus 50 voltage equals to 100 voltage. But here drawback of this method is, here the drawback is here. What is the drawback here? So huge amount of power loss occur. So I square, so V square by R. So this 50 square by R, that equals to 2500 by R. Huge amount of power loss in the circuit. So this is one drawback. So now here another way of reducing the voltage by using one switch. So this is a voltage, this is 100 volts, and this is one load 50 volts. So now here what will happen? So by inserting one switch in between this input and output, so what will happen? So first here, so turn on some duration. So switch is turned on for some t T on duration. So this is T on duration. So after that, so this is suppose 100 volts input voltage, and now here this is 100 volts voltage turn on duration. Suppose this is T on duration, it will be turned on. So after some time it will be turned on. So total time period is T. So now here this time period is T. So now by taking average value, so by taking average value of this one, output voltage is this output voltage V0 and V in is output voltage equals to T on divided by T on plus T off, that is time period. So that is into Vs supply voltage. Vs supply voltage. So now here V0 equals to T on by T into Vs. V0 equals to delta into Vs. So now here delta is a duty cycle. Delta is a duty cycle, means by changing the duty cycle. So we can change the output voltage. So by reducing the voltage, so this delta value is always 0 to 1. So now here by changing, if I want the 50 volts at output voltage, so now here V0 equals 1 by 2 into Vs. Vs equals to 100 means that is 50. In this way, we can change the output voltage. We can make the output voltage variable. So now here, what is how to? This is one switch, and now here this is the output voltage. This is Vs and this is V0, and I am attaching one switch in this, but it is not suitable for practical applications. Why? Because here current voltage harmonics and current harmonics are there. So to reduce the current harmonics, I am attaching one inductor in series with this one, that is IL. So to reduce the voltage harmonics, so now here I am attaching the capacitor. So now here when we turn off this switch, so there is a energy stored across the inductor. So if there is no in turn off means there is no closed path here, there is no path for discharging. So now here for that purpose, if there is no path for discharging means already there exists one energy in the circuit, so there may be a sparks. So because of that reason, I'm inserting one diode. So that is freewheeling diode. So this is the K, C, and this is the D. So this is actual circuit diagram for chopper. So now here, so what are the control strategies? So now here, chopper can increase or decrease. Increasing means step up, means that is boost converter, and decrease means that is buck converter. Increase or decreasing means that is buck boost. So here DC lever as its opposite side, and now it serves as a purpose DC circuit of process. So transformer is also increasing voltage or decreasing voltage without changing the frequency, but in case of AC circuit, but here it is a DC, we can call it as a DC. Transformer definition we already know, either increasing voltage or decreasing voltage of AC, but here either increasing voltage or decreasing voltage by using chopper, that is DC chopper. So here for low power applications we will use here GTO, gate turn off device, and IGBT, integrated gate bipolar transistor, power BJT, power bipolar junction transistor, and next power MOSFET, power metal oxide semiconductor field effector transistor, thyristor, or SCR, silicon control rectifier. For this is for high frequency application, these are for low frequency applications. So now here in this, so now here the device, the chopper is switch is denoted in the dotted line for simplicity, and now when it is closed, current flows the direction in the arrow mark direction. So now control strategies. So first, there are two types of control strategies. So output voltage can be changed by using these two control strategies. First one is a time ratio control strategy, and next here time ratio control strategy, and second one is a current limit control strategy. In this again two types. So constant frequency, and next here variable frequency strategies. And now here constant frequency means here, so this is also known as a constant frequency system or pulse width technique, pulse width modulation technique, and this one is also known as a variable frequency system or variable modulation scheme. And now here in this, output voltage is depending upon the duty cycle. In the previous slide I already explained V naught equals to delta into Vs. So this is depending upon the this delta value only. By changing delta value equals to T on by T only, this one. So now here V naught equals to T on by T into Vs. So this is by changing the duty cycle we can change the output voltage V naught. So by both the methods, so both this time ratio control and current limit control, so use some technique to vary the duty cycle. So here only thing is in the current control, current limit control, time ratio control, so only is here duty cycle we need to change. So that I will explain. So first I will explain constant frequency system. So that means pulse width modulation system. So first here time ratio control. So in that again two types. So time ratio control means here the method by controlling output voltage by changing T on or by changing frequency. So these are the two methods. So now here let me write the, so V naught equals to delta into Vs, and V naught equals to T on by T into Vs. So now here, by changing the delta can be changed by either in time ratio control method or current limit method. So in the time ratio method here, so V naught equals to T on by, so T means here T on plus T off into Vs. So now here from this equation, here by changing the T on. So if you change the T on, so the period of the chopper, and by keeping this is constant. One should be constant and other should be variable. So here either T on should be constant or T on should be variable. Here first method is this T on is variable, T on is a variable, and this is a constant. This is the first one. Or, so now here T on is off. T on is a constant and T is a variable. Chopping frequency means T equals to 1 by F. Chopping frequency is constant. So means by changing the chopping frequency is variable. So by changing the chopping frequency, we can change the time period, and by changing the time period, we can also change the output voltage. In this way, we can change in two ways we can change the output voltage. Either T on is variable, time time period is constant, that means frequency is constant, or T on is constant, time period is variable, or frequency is variable. In these two methods, I will explain. So now here this formula. So now here this is V naught equals to delta or alpha. Delta means delta value is always between 0 to 1. So by changing while keeping T constant, results will be output voltage. So now here, so there are two types of method: constant frequency. So that is constant frequency first method, or variable frequency. So by changing the chopping frequency. So now here, first method, constant frequency. That constant frequency means constant time period. Means that is pulse width modulation, means only T on is variable. So T on is changing. So frequency or time is constant. So T on is changing means that is pulse is changing. So turn on, this pulse is changing. So but time period is fixed. So it is T on is changing. So see in this one, in this technique, the time period of chopper is maintained constant, is maintained fixed, and change in the duty cycle is achieved by, so duty cycle V naught equals to delta into Vs. So now here T on divided by and T into Vs. So V naught equals to. So now here, since the time period is constant, this is constant, but T on is changing. So that means frequency is constant. So time T equals to 1 by S. So T is constant, T means chopping frequency will be constant. Hence, this is also called as a constant frequency or constant time period. It should be noted that, so by changing the T on, so this one, so the width of pulse width also changes. So that is the reason width of the pulse is changed, means the output voltage will also change. Because of that reason, this method is also known as a pulse width modulation scheme. So this voltage control of the chopper method is also known as a pulse width control of the method. And now here in this, I will explain first. Here time period is fixed. So T is fixed, means frequency is fixed. Only I am changing the T on. So T on equals to 1 by 4th of T. So in the first case, in the figure, so here T on is 1 by 4th of total time period. So here what will be the output? V naught equals to 1 by 4th of Vs automatically. So now here delta equals to 1 by 4 here. So this is fixed. So that is Vs by 1 by 4. Now here output voltage is 25% of input DC voltage. Now here I want to increase the output voltage. So what I need to change? So this T on should be changed. So now this T on should be simply 3 by 4th. So 3 by 4th means here I want to increase 75% of increasing voltage. So now 3 by 4th of time period. So that we can increase the output voltage. So here by changing the alpha, by changing because of this T on only. If you increase the T on, output voltage will be increases. So now here alpha can be changes from alpha value is always from 0 to 1 or delta value. So the output voltage can be changes from 0 to supply voltage depending upon the alpha, depending upon the T on in case of pulse width modulation technique means constant frequency. This is fixed, but this is T on is changing. So now here second method is a variable frequency means frequency modulation scheme. In this scheme, chopping frequency is varied. So this is varied, this is changing, but this T on is fixed. T on is fixed, but frequency or T is constant. In this, so the chopping frequency is varied or chopping time is varied. So either maintain T on or T off. Either you can fix T on or T off. So that is a reason. So duty cycle of is varied. So by changing denominator, V naught equals to delta into Vs T on by T into Vs. So T on, and here I am changing T. So T on is fixed. T on is fixed means you need to change T off only Vs. So if you change the T off automatically, so this duty cycle will be changed and output voltage will be changes. So this by controlling duty cycle is also called as a frequency modulation scheme. And now here in this case same. So T on is 3 by 4. So the duty cycle is um, 0.25. So the output voltage will be 0.25. So now here T on is 3T by 4. So the duty cycle is 0.75. So that is 0.75 volts output voltage. So here T off may be varied to get the duty cycle and hence the output control voltage. So here pulse width modulation scheme has disadvantage as compared to the pulse width modulation of output voltage control here. So what are those disadvantages here? So chopping frequency has to be varied over the wide range of output voltage control in frequency modulation. So that is first one. And filter design for such a wide frequency variation is quite difficult, and wide frequency variation is required for control of chopper duty cycle. And now here that last one is here there is always chance of interference with signaling and telephone lines in frequency modulation scheme. Large off time in this scheme may take the lead current discontinuous in. And now here, so which one is the better? So now here in the pulse width modulation is the better as compared to the variable frequency means frequency modulation scheme. However, it is pulse width modulation has its similar limitation. So here in the PWM scheme, so on period cannot be reduced to 0. So 0 we cannot change it to 0. So now here the low range of duty cycle is not available in this technique. So this can be achieved by increasing the chopping frequency, chopping period, or decreasing the chopping period of the signal. Next method is a current limit control method in this method. So this is the diagram. So now here output voltage having this limitation. So I naught maximum and I naught minimum. This is the ripple in the output voltage. T on and T off. Turn on and turn. Delta means T on by T off plus T on. That means V naught equals delta into Vs, and delta means T on by T. So here in this current limit, so now here the output voltage reaches to 0, the circuit will be turned off, and when this circuit, this is when output voltage reaches to the maximum value, now it will be turned off. So now here during turn on, it reaches output voltage from I naught minimum to the I naught maximum, and during turn off, that I naught is maximum time to the minimum I naught maximum to the I naught minimum. So it is always continuous. So that we will see first. Current limit control is one of the output voltage control strategy. So in this case, so T on and T off circuit is governed by previously set of load currents, and now here this is switched on. This is switched on when it is reaches to minimum value in this case. So when it will be off when it is reaches to the maximum set value. And now here the maximum and minimum values are the load currents IL, that means I naught maximum and I naught minimum respectively. So these are the independently, these values are independently set values. And now next case here, so the current is here rises from its minimum value to the maximum value is known as a T on time. So now here this is a T on time. So current rises from this I naught minimum to minimum value to the maximum value. So this duration is known as a T on time. And now here T off time means so decaying. So this is rising current and decaying current from I naught maximum peak current value from 2 and I naught minimum. So this duration is known as a so T off duration, and this switch is this circuit, the chopper is switched T off when so it reaches to the maximum. So when it is reaches to the minimum value, so that is on. So here our load current shows it fluctuating. Here load current is showing it is fluctuating between I naught maximum to and I naught minimum, and the load current is always continuous. So it is not discontinuous. So now here what will happen? So it will never be discontinuous. So duty cycle is adjusted in such a way that load current never be discontinuous. So now here switching frequency can be controlled by set values of I naught and I minimum, I naught maximum and I naught minimum. So now here this one is V naught equals F into, this means T on by T means that is output voltage, and that load current is not pure DC. That is not pure DC. So it is having some ripple. So the value of ripple equals to I naught maximum to I naught minimum. So how you will reduce this I naught ripple? So now here to reduce this ripple content in the output voltage, load current, so the chopping frequency, so that is frequency equals 1 by T equals to T 1 by T on plus T off. So this chopping frequency has to be increased, so which in turn lead to more switching losses. So now here, so that current limit control involves feedback loop, so that triggering circuitry for the chopper, therefore more complexities. So this is the reason pulse width modulation is commonly chosen controlling strategy of power control in the chopper circuit. So now here, these are the problems. So first problem, a chopper circuit is operating on so time ratio control strategy at frequency is 2 kilohertz. So frequency equals 2 kilohertz means 1 by t equals to 1 by 2 into 10 power 3, and on 460 volts supply voltage, that Vs equals to 460 volts. If the load voltage is V0 equals to 350 volts. Here step down voltage is decreasing volts. Calculate the conduction period of thyristor in each cycle. So now let us take V output voltage. So Vs equals to delta into 350. So V naught. So output voltage equals to 360 equals to delta into 460. So here 350. So now here 460. From this you can calculate 350 by 460. Here you calculate the delta value. So now here, after getting delta value, so this is the time period t. So delta equals to t on by t of delta equals to t on by t. So that equals to, so now here t is given. So t is given, delta equals to 350 by 460, that equals to t on e by, so this frequency equals to, here that is 1 by t. So here, so this is 1 by t means here t equals to 2 into, so now here this equals, this is not, so 2 into 10 power minus 10 power 3. So now here this is 1 by 2 into 10 power 3. So now here this is 350, 460 and 1 by 2 into 10 power minus t naught. So now here t on time is here 0.38. So first here what you have to calculate here, output voltage, input voltage is given, output voltage is given. From this calculate the delta. So delta equals to t on by t. So t means here frequency. Frequency equals to 1 by f, that equals to 2 into 10 power 3. So now here this equals to t on into f. So f is in the denominator here. So now here t naught is you need to calculate. So that equals to 0.38 milliseconds. So t off also you can calculate. So t off, t on plus t off equals to t, that equals to 1 by f. Input voltage in the second problem, input voltage here step up transformer, step up chopper. So V naught Vs equals to 200 and V naught equals to 600. So now here V naught equals to delta into Vs, and now here if conducting stopping frequency, delta first you calculate it. So step up chopper. So how we will calculate here? So now here this is, so VDC equals to, so now here first calculate the delta value. So V naught Vs equals to 200 and T on is a 200 microseconds. So now here compute the chopping frequency, that is f, that equals to 1 by t. T you need to calculate. So how you will calculate this one? So this formula I am explaining. So VDC equals to, VDC means that is Vs equals to V into T by T minus T on. So that equals to, so in the boost converter what is the formula? So V naught equals to Vs by 1 minus D. So that is the formula. So now here let me derive this one. So now here V naught, so this is a Vs and this is a V naught. So this equals to this equals to, so V naught is equals to 1 by 1 minus T on by T. So now here VDC output voltage. So now this is a Vs. So now this equals Vs by 1 minus D. So this is a formula. So now here Vs is given, output voltage is given, V naught is given 600 and input voltage is given, T is given, T you need to calculate and T naught is given. So now here from this you can calculate the T value. So now here chopping frequency, how you will calculate chopping frequency? Chopping frequency here you got the T value, T equals 1 by F and that 1 by 1 by F equals 1 by T, and now here T equals 1 by 3 into 10 power minus 6 means 300 microseconds. So here that is chopping frequency. So now here pulse width is half for constant frequency operation. So pulse width is half for one means here, so T on should be half. So then the new output voltage. So the new output voltage means, so this 200, that is 100 microseconds. So now here this one equals T and T is given, so that is this much and this is 100 only. So now the new output voltage equals to 300 volts. And now here a DC chopper has a resistive load of 20 amperes. And now here that input voltage is 200 volts and the chopper is on. So the drop is 1.5 volts and the chopping frequency is 10 kilohertz. And the duty cycle is 80 percentage, means that is 0.8. So now determine the output voltage, average output voltage and chopper on time. So now here we know this formula, T del duty cycle equals to T on by T, that equals to 0.8. So we know very well this formula. And now here input supply voltage equals to 200 volts and load current, load resistance, this is not ohms, this is not amperes, ohms, the load resistance is 20 amperes. So now here output voltage, how we will calculate the output voltage? Here determine the output voltage. So now here T on by T into Vs minus, there is a drop. So here actual formula is here, so V naught equals to Vs into delta, but here delta equals to T on by T, but here output voltage there is a resistive drop. So because of that resistive drop here 1.5 volts. So now here we need to calculate 220 volts is the input voltage, 220 minus 1.5. So now here this is your output voltage 174.8. And now here chopper turn on. So turn on time equals to T on equals to delta into T and T off equals to 1 minus delta into T, that we know very well. And what about the T? T equals to, what is the formula? So now here T equals to, T is given, so that equals to T equals to chopping frequency is given, so chopping frequency equals 1 by F. So T equals 1 by 10 into 10 power 3, so that equals to 0.1 into 10 power minus 3 and means 100 microseconds. So now here this is 100 microseconds and this is duty ratio T on equals to 80 microseconds. So now here what about T off? T off equals absolutely 20 microseconds. 20 plus 20 means 80 plus 20 means that is 100 chopping time period. Next, fourth problem. In the DC chopper, the average load current is 30 amperes. The chopping frequency is 25 hertz and the supply voltage is 100 volts. T on and T off periods. So in the previous case, we have calculated T on or time period only, but here in this question, you need to calculate T on and T off of the chopper if load resistance is 2 ohms. So now here load current is 30 and load resistance is 2 ohms. So now here load voltage, input voltage Vs equals to 110 and V0 equals, what will be the V0 value? 2 into 30, that is 60 volts, step down chopper. 2 into 30, V is equal to IR. So 30 into 2, that is 60 volts. And chopping frequency T is given, so that is 1 by F equals to 1 by 250. So T is also we got, easily we can calculate, so that equals V0 equals to T on by T into Vs. So Vs is given, V0 is given, time period is given. So R T on into F into Vs. So all the parameters given, we can calculate T on easily. So now here T on equals to 1 by 250, that equals 4 into 10 power minus 3, 4 milliseconds. So now here, what is the formula for VDC? VDC equals to this formula. So VDC V0 equals to delta into Vs. So now here delta equals to output voltage by, that is 60 by this 110, that equals to 0.5. So now easily we can turn T on equals to delta into T, and T off equals to 1 minus delta into T. So now here T on equals to delta into T, so that delta or duty cycle is equals to 0.545 into this time period, that equals to 4 into 10 power minus 3. And now here you can substitute in this formula also, or you can subtract this total time period from this total time period to and T on. You will get, so here T on is 2.18 millisecond and T off is a 1.82 milliseconds. So now here these are the problems. So now here I hope this chopper concept, why we need chopper definition. Next, what are the control strategies, time ratio control, and in this time time ratio current limit control, and here the time ratio control, there are problems in this pulse width modulation control strategy. In this T on is only changing and T is time period is constant. In the frequency modulation, frequency is constant, means variable, and time period is variable, on T is on. So this everything we discussed, and some numerical problems also we discussed. I hope all these concepts and problems are clear to you. If you still have any doubts in this lecture, you can comment in the comment section below. I will answer to your queries. Thank you. Thank you very much to you all.
Like, share and subscribe. Hit the bell icon for more updates.